On 5.3, definite integrals and antiderivatives. We call this antiderivatives because we're going to go the opposite direction from what we had derivatives. But before we do that, there are 5 rules of the antiderivatives that we need to go over. So rule number 1 says that if the order of integration, so this is this S shape that we're going to introduce to you, and the S shape is called the integration, or sometimes they call it antiderivatives. We have a lower limit and then the upper limit right there. So that's going to give us the limits. This is the equation that will be given right there. And then dx. Now dx is like a period in a sentence, so you have to make sure you put that. But it's also reminding you it's a derivative of x right there, the derivative of x that you had already done. So that's what this is right there. So whatever that variable is, that's what this variable is also. So if it's y, it's going to be dy, etc. Okay? So the rule for one of the rules, it says order of integration, said that lower limits and upper limits, normally A comes first, that's the smaller number right there, and then B is going to be the larger number. So in this case where the B is actually on the bottom and A is on the top, you're going to have to flip it up right here, make A go in the bottom, the smaller limits, and then the upper limits being B, and then you also have to add is a negative out here. So whatever that answer is of this, we're going to include as a negative at the end. Rule number 2 says the zero rule. So zero rule says that if you have the same limits, whatever these two limits are, once we do the integration or the antiderivative and we substitute these numbers in, they're always going to come out to 0. So if your limits right here are exactly the same, you know for a fact that the final answer will be a 0, so you don't have to actually do the antiderivatives for that. Okay? Rule number 3 says it's a constant multiple. So constant multiple means basically that you have a number right here, that's our k, and then you have an equation right there, a d of x. So normally that k right there is like 3x to the second power or something like that, where f of x is some kind of variable. So if you have like a number 3 or any number, you can always factor it out right there of the integration symbol right there, and then do your still lower limits, upper limits, equation, and then the period right there. Okay? We also have as a negative, so if you have a negative in front of all the variables right there, you can also factor out a negative right there. So a number and a negative can be factored out. That's called a constant multiple. Then rule number 4 is a sum and difference. So sum and difference just basically says that if I have the integration with the lower limits of A and upper limits of B, and to a different equation is attached by either a plus or a minus, we can actually separate this into 2 parts. So this right here, the first part will be the integration of lower limits, upper limits, still the same limits right there, but I'm going to take my f of x right there, put f of x, put a period right there, that d of x, and then have a plus or a minus depending on what that operation is. And then we do the integration, the second part. So the second part is still the same limits right there, upper limits and lower limits. And then we take the g of x right there, we take it outside right there, and then put the period right there. So we're going to separate the 2 separate integrations. Now sometimes you'll need this right here because depending on what the equation is, it's easier to see it if you separate the 2 equations right there. Okay? And then the last one is called the activity. So activity just basically says that if I have the limits of A and I have the limits of B of f of x. Now notice this is f of x and this is also f of x. It's not the same as the previous number 4 rule, because number 4 says that you can have f of x and g of x. In this case, it has to be the same equation. So then the limits of this right here is B, so it's the same number as this right here, and the limits of C right there. So we can separate this right here, and if it's separated, we can also put it together as the limits from A to C, because we're saying whatever this function is, the f of x equation, the limits for A to C is going to be the same. Wherever that B is that meets right there, that's this part right here. Okay, so those are usually the 5 common rules. So now we're going to take those rules and apply it to the example. So the example that we have is this right here. This is given. It's kind of like when we did the composition f of g and g of f, those kind of stuff where f was given, g was given, and sometimes they even threw an h. So an h was given, and then you had to do operations with that. So similar to that, this limits right there is given from -1 to 1 of f of x dx, and it's equal to 5. And then also from 1 to 4 of f of x dx is equal to -2, and -1 to 1 of h of x is equal to 7. So with this also, I kind of like to see it as an area problem. So when we put it on a number line, I'm saying from -1 to +1, the area of whatever this function is equal to 5. So all of this right here, just think of it as the area of this, the shaded part of it is equal to 5 right there. Okay? Then we have is from 1 to 4. So if I have from 1 to 4 right there, the area of that is going to be -2. So down here, whatever the area is, I'm going to go down here because usually negative is going to be underneath the x-axis. And then from -1 to 1, -1 to 1, and the area of that is going to be 7. So notice that it is not the same function, right? Because the previous one was f of x and this is h of x. So they're different functions. That's why even though the limits are the same from -1 to 1, -1 to 1 is the same limits, but this is f of x, and so whatever that f of x is, we're saying the area of that is 5, and this right here, the area of this is 7 right there. Okay? So now using that, we're going to do the first part. So the first part says, now find the area when it's between the limits of 4 to 1 of f of x dx. Well then now, using the 5 rules that we went over, we said that one of the rules was that the order was important, right? The order meaning that the limits has to be from the smallest to the largest, from A to B. And in this case, the order is 4 and 1. So 1 is smaller than 4 right there. So they have it wrong right here as far as the limits. So then we're going to switch the limits right there and put a negative out there. So that's the rule that says right there we have to put a negative out there. Okay, so that's what we did right there. We put a negative. Now, the 1 to 4 right here of f of x, that's given up here from 1 to 4 of f of x, and we said the area is -2. So I'm going to substitute that -2 right there, and this negative out here and this negative out here will give us the +2 as a final answer. Okay, now part B. So the limits from -1 to 4. So my first thing I'm looking at is the limits to see if it's correct. My limits are correct. I have the smaller one on the bottom. The top one is the bigger one. So then I ask myself, okay, so looking at this, do I have -1 to 4? I don't have that because I have is -1 to 1 and then 1 to 4 for f of x, not h of x, because that has nothing to do with this part right here. It says f of x right there. So we can see that -1 to 4 can also be combined with these two right there, right? I can go from -1 to, -1 to 1, right? If I go on the number line from -1 to 1, and if I continue on from 1 to 4, it's the same thing from -1 to +4, all of that integration right there. Okay, so let me draw that on a number line right here so that you can see that. So I can say from -1 to 1, right, and then 1 to 4, I know the areas for that. So I know the areas from -1 to 1, that was given as 5. So the area of this is 5 right there. And then from 1 to 4, we said the area from 1 to 4 is -2. So down here at -2. Okay? So then from the integration from -1 to 4, that's this, all of this right here from -1 to 4, I'm just basically putting those two areas together and we're adding them together. So that's what I did right here. I separated from -1 to 1 because I know that area right there, plus 1 to 4, and I know that -1 to 1, the area is 5, and then the area for the other one was -2, so that's how we got this. And we just combined like terms, and that gave us 3 as the final area from -1 to +4. All right, then we do the last part. So the last part right here is -1 to 1, so I'm looking at that, the limit looks good. So then I just have as 2 f of x plus 3 h of x, which then says, it was, I believe, the sum of difference, right? We can actually separate them. So that's what we're going to do for the next step. I'm going to separate them. So I have is the 2 out here, I have f of x plus 3, then h of x. Notice the limits are still the same right there, limits still the same. And then from there, one of the rules says that if I have a constant, right, a number out here, a number out here, we can put it in front. So that's what we do for the next step right there. We put it out in the front right there. So I know the limits from -1 to 1 of f of x, right? -1 to 1 of f of x is 5. And I also know the limits from -1 to 1 of h of x. Now that's where the h of x is going to come in. So h of x is going to be 7 right there. Okay? So then if we put those together, then we're going to have something like this, where the 2 right there, the coefficient for 2 right there is this 2. Area of this right here we said was 5. We have a 3 right there, so we put a 3 out here. We said the area of all of this right there is equal to 7. So then we put them together mathematically. That comes out to 31. Okay? So that's what we're going to do, is going back to then, again, the rules, the 5 rules. You need to know the 5 rules so to be able to do the rest of the problem.